Hello everyone, welcome back to my YouTube channel. Today I'll be presenting about the Fourier transform and its application. We'll learn about the what is the transform and its mathematical formula, the function about the Fourier transform and its representation in time domain as well as in frequency domain. And we'll also learn about the discrete Fourier transform and the fast Fourier transform, few of its application and the summary. Let's talk about what is transform. So the transform means a function that results when a given function is multiplied with a so-called kernel function and the product is integrated between the suitable limits. Its mathematical representation can be f of s is equal to Laplace of f of s, that is equal to integration of 0 to infinity e to the power minus s f of t into dt. Properties of transform is that they convert a function from one domain to another domain without any loss of information. The Fourier transform means it converts one form of time domain to another form of frequency domain. We represent the formula for Fourier transform as f of omega is equal to 1 by root of 2 pi whole multiplied by integration of minus infinity to plus infinity f of t e to the power minus I omega t into dt. The formula is given in slide. Representing the time domain and frequency domain. Here in the given graph, the time domain is in x-axis and pressure is in y-axis. This means this will show us how the properties change over the time. Means whatever property we consider, let it be the air pressure or the speed of the vehicle or the speed of the light, it can be anything. All these will come under the time domain, that is whichever property changes in accordance with the time, that is called as time domain. Frequency domain simply means how properties change over frequency, same as time domain where it changes over time, and frequency it changes over frequency. Considering the example as amplitude changing over the frequency, the graph is shown here only. Some of the example is that we human ear cannot hear water, the sound waves that travels into our ear, but we hear a constant tone. That is possible by the spiral form of figure, that is the focula in the ear, where the hairs responds to higher frequency and the lower hairs responds to the lower frequency. This may often is works as a easier form of that converts the frequency domain, or we can also tell that often it is easier to work in the frequency domain. Then in 1807, Jean Baptiste Joseph Fourier showed that any periodic signal could be represented by a series of sinusoidal functions. Sinusoidal functions, you can here see that a sine function, you can also see a square function over here represented in the form of graph. Here we can observe that the time domain wave, that is different types of signals and the frequencies are shown in the 3D format, that is with respect to time domain and the frequency in y-axis and time domain in x-axis, and also the frequency domain is also shown in figure. We can just analyze the time domain waveforms and the frequency domain waveforms here itself. Now coming to the Fourier transform. Because of these properties that we see in the earlier slides, we come to some of the extent up to we derive some formulas, that is Euler's formula. We have two of the Euler's formula. One is e to the power I theta, which should be equal to cos theta plus I sin theta, and e to the power I omega t will be equal to cos omega t plus I sin omega t, where I will be equal to root of minus 1. The Fourier transform also takes place in the frequency domain. We see it with a formula as f of omega is equal to integration of minus infinity to plus infinity f of t e to the power minus I omega t dt. Discrete Fourier transform. In practice, we often deal with discrete functions, that is the digital signal. For example, discrete variation of Fourier transform is much more useful in computer science. Its formula is represented as f of j, which is equal to sigma k to the power k equal to 0 to n minus 1 xk e to the power minus 2 pi I divided by n jk, where j is equal to 0. Fast Fourier transform in many of the technologies introduced in the reducing the computer time to zero, that is n to n log n. Most popular one is redax to dissemination in time, that is DIT. FFT Coley-Turkey algorithm. We can look into the algorithm in the slide, where f of j is equal to sigma k equal to 0 n by 2 minus 1 x2 k to the k into e to the power of minus 2 pi I divided by n j into 2k. This formula is similar to the formula we have discussed in the previous slide. It is just the advanced calculation of the formula. We can go through it in the slide. Coming towards the applications of Fourier transform, this can be used in image processing. That is, it can be used instead of time domain. Now, that is the normal image spaces. In frequency domain spaces in which each image value at image position f represents the amount that the intensity value in image I vary over a specific distance related to f. Applications in frequency domain in the images is that if there is a value that is 20 as shown in the figure over here, at the point that represents the frequency 0.1 or 1 period over 10 pixels. This means that in the corresponding domain image, the intensity of the value varies from dark to light and back to dark over the distance of 10 pixels, and this contrast between the lightest and the darkest is 40 gray. Even there are many applications that is the spatial frequency of the image can be represented at the rate at which the pixel intensities changes. In the picture that is shown over here, the center, near the center, it is high frequency, at the corners it is low frequency. In image filtering, we can see some of the filters that image that is obtained by the filters. We can look at the specimens image. We can see the freehand filter power spectrum. We can also see the reconstructed image of the specimens image. There are other applications too, that is the signal analysis, sound filtering, data compression, partial differentiation equation, multiplication of large integer. All the last two applications we study vast, that is majorly in engineering, and the other three comes under the industrial sectors. It is mostly applicable over there. Summary, when we come across, we have learned about the transformers mathematical equation, also about the Fourier transform, the time space domain, frequency domain, and the applications in those domains. We have also learned many of the applications of each of the Fourier transform, that is in whether it might be image sorting, any of the things. So I conclude my video by thanking you all for listening so long. Thank you so much.